Hi everyone, welcome to the tutorial Docker step by step section 2.2. So in this video we are going to see why containers. So why containers? So in non-technical words, the software industry has changed now. Before, monolithic applications, that means the huge applications and long development cycles, single environment, slowly scaling up things. But now decoupled services, fast iterative movements, multiple environments, quickly scaling out. Deployment becomes very complex. Many different stacks like languages, frameworks, databases, many different targets, individual development environments, pre-production, QA, staging, in production on physical, cloud, hybrid coming. But the deployment problem, so if you see the multiplicity of stacks, if we have multiplicity of stacks, so do services and apps interact appropriately? No, right? At the same time, multiplicity of hardware environments. In this case, can I migrate smoothly and quickly? Definitely no. So in these cases, the matrix check we can check in this table. So static websites, web frontend, background workers, users DB, analytics DB, queues, one column. So in the rows, development VM, QA server, single production server, clusters, public cloud, contributor and laptop, customer servers. So here and all the deployment has to happen. So intermodal shipping containers. See this in this picture, we have different products, right? Like multiples of goods. A standard container that is loaded with virtually any goods and stays sealed until it reaches final delivery. So in this case, if I use the container, do I worry about how goods interact? Example, coffee beans next to the spices? No, right? So in between can be loaded and unloaded, stacked, transported efficiently over long distances and transformed from one mode of transport to another, right? So multiplicity of methods for transforming and storing is happening here. So can I transport quickly and smoothly? Example, from a boat to train to truck and ship? Definitely yes, correct. So we'll come to shipping containers for applications. So multiplicity of stacks here. So static website, user DB, web frontend, queue, analytics DB. So an engine that enables any payload to be encapsulated as a lightweight, portable, self-sufficient container. Do services and apps interact appropriately? Yes. So multiplicity of hardware environments that can be manipulated using standard operations and run consistently on virtually any hardware platform. Can I migrate smoothly and quickly? Definitely yes. Eliminate of the matrix. So if you see the question marks previous slide for static website, web and front end, background workers, users DB, analytics DB, queues, everything now replaced and, with a container, and it reached to the development program VM, QA servers, single production servers, and queue, public cloud, contributors, laptop, and customer servers. Results: Dev to product reduced time, continuous integration, job time reduced by more than 60%, better application management. So now in technical words, why containers? Escape dependency hell. So dependency is a hell, right? So write installation instruction into an install.txt file, Use this file, write an install.sh script that works for you. Turn this file into a Docker file. Test it on your machine. If the Docker file builds on your machine, it will build anywhere. Rejoice as you see escape dependency hell and works on my system machine. So never again work in DevOps problem now. Why containers? Again, technically, implement reliable CI easily, continuous integration easily. So build test environment with a Docker file or Composer file. For each test run, stage up a new container or stack. Each run now in a clean environment. No pollution from previous tests. Way faster and cheaper than creating VMs each time. Why containers? Again, technical. Use container images as build artifacts. Build your app from Docker file. Store the resulting images in a registry. Keep them forever or as long as necessary. Test those images in QA CI integration. Run the same images in production. Something goes wrong, roll back to previous image. Investigating old regression. Old image has your back. Images contain all libraries, dependencies, etc. needed to run the app. Formats and APIs. Before Docker, no standardized exchange format. Containers are hard to use for developers. As a result, they are hidden from the end users. No reusable components, APIs, tools. After Docker, standardize the container format because containers were not portable. Make containers easy to use for developers. Emphasize on reusable components, APIs, ecosystem of standard tools. Improvement over ad hoc in-house specific tools. Shipping. Before Docker, ship packages with DB, RPM, gem, jar, homebrew. Dependency hell. Work on my machine is a question. Base deployment often done from scratch. Deboot scrap and unreliable. After Docker, ship container images with all their dependencies. Images are bigger but they are broken down into layers. Only zip layers that have changed. Save disk networking and memory and usage. DevOps. Before Docker, drop a tarball or commit hash with instruction. Dev environment very different from production. Operations don't always have a development environment. Operations have to sort out differences and make it work. Shipping code causes friction and delays. After Docker, drop a container or a compose file. Operation can always run with that container image. Operations can always run that composer file. Operations still have to adapt to the production environment, but at least they have a reference point. Operations have tool allowing to use the same image in dev and production. Devs can be empowered to make releases themselves more easily. Now container is equal to cheaper than VMs. How? So how the VMs are built? We have an underlying server. In the underlying server, we'll be installing the ESXi host operating system. So it is basically a hypervisor layer it will have. So on the top of the hypervisor layer, we'll be installing the guest operating system separately. So each guest operating system is a VM. So in that guest operating systems, we'll be having bins and libraries. So on top of that, we'll be installing application A. And if you want and to run the application B, we'll be having a separate and a VM again. And for the application C, we'll be having a separate application. Again, if you want to do one more application, you need a separate guest operating system. Right? But in case of containers, we'll be having a server. There we'll be installing an operating system. So either a Windows, Linux. So that images, whatever we are deploying, it will have its bins and libraries, uh, runs as a microservice, and in that the application A will be running. So if you want to run an application B, just use another image. So and if you want to use application C, just use another image applications C run on that. So containers are isolated, but OS kernel and were appropriate bins and libraries. Result is significantly faster deployment, much less overhead, easier migration, faster restart. Containers easier than VMs. Instantly live. When you create or import an app with Heroku, it's already live on the web. No configuration or deployment necessary. Create and edit online. Edit all your code and data right in your browser. You can access it anywhere and there is nothing to install. Share and collaborate. Make your app public to the web or private to users you specify. Add collaborators who can edit the app with you. Import and export. Easily import and export your app's code, schema, and data at any time with just one click. So, thank you everyone. So, this is all I had for what is containers. So, with this, we are done with the basics of containers. And in the coming sessions, we will be going in depth into the containers in practical manner. So, thank you everyone. Bye.